Now let's do an example for an IUPAC name for a substituent containing alkane. Write the IUPAC name for the following compound. So we have this question. We'll figure it out how we can write the correct name. When you have this type of question, first you need to look at the carbon chain and determine the longest carbon chain. First, pause the video and try to do this problem by your own. And once you have your answer, come back and check your answer. Okay, so to determine the longest carbon chain, I can say this has the 5 carbons in its longest carbon chain. If I draw the chain, it will look like this. So this has to be a pentane. Okay, now we have two substituents. The next step is to number the carbon chain starting from one end, from left hand side or from right hand side. The rule is when you number the carbon chain, you need to start the numbering from the end which is closer to one of the substituent. Now in this case, if I start from left hand side, this side is much closer to the carbon containing chlorine group. So I can start from, I will start from that end. 1, 2, 3, 4, 5. Okay, if I started from this end, the substituent is in the third carbon atom. So that's why I chose the left hand side to start numbering. So that's how you figure out from which end you have to start the numbering, because you will get two different names if you start from the two sides. Okay, now we need to locate the positions of the carbon atoms which contains the substituents. Now we have chlorine atom on the second carbon atom and methyl group in the third carbon atom. So now the naming need to contain the positions of these substituents. So first I will start from the chlorine atom. So I can write, since the chlorine atom is in the second carbon atom, I can write 2-chloro. So as you see, you need to put a dash in between 2 and chloro. So whenever you are naming a halogen, you need to end it with O. So that's why I wrote chloro. 2-chloro. So I already wrote the one of the substituent. Now we have another substituent to put the location of the position on. I will put another dash, 3-methyl. 3-methyl, and then I will just write the name pentane. 2-chloro, 2-chloro 3-methyl pentane. So that's the correct name of this compound. Okay, let me write it again. 2-chloro 3-methyl pentane. So we started numbering from here. And that's how we position the chloro group and the methyl group. Okay, so why did I first started with chloro, not methyl? So you have to go with according to the alphabetical order when you choose which one to write first. So chloro comes first according to the alphabetical order. So that's why I started with chloro, and since it's attached to the second carbon atom, I wrote 2 dash. And since methyl group is attached to the third carbon atom, I put number 3 in front of methyl. Always the numbers has to be separated with a dash. And there's no space in between methyl or pentane. We just write it as methyl pentane with no spaces. If you put a space, that is not correct. Remember, these are IUPAC namings. So there is only one and only one name for each compound. Okay. So naming cycloalkanes with substituents. So we can put substituents to the cycloalkanes as well. There is one example here. An ethyl group is attached to a cyclohexane. So in this case, so since there's only one group attached, you can just write the substituent's name first, ethyl, and then cyclohexane. Do you remember if there was no any substituent, we just wrote it as cyclohexane. That was the name. So in this case, you just write the name of the substituent in front of the name cyclohexane name. No spaces in between ethyl and cyclohexane. Naming haloalkanes. So these are the alkanes that contains halogen atoms attached to the carbon atoms. And again, we need to put the substituents in alphabetical order. So this is very similar to what we did before. Some examples of haloalkanes are given here. So if there's a chlorine atom attached to a methyl group, we can first we need to start with chloro. We can say chloromethane. So since there's only one atom, it is one atom of carbon, it is methane. The substituent names comes first, chloromethane. In this case, it's bromoethane because there are two carbon atoms. We name it as ethane, and bromo comes in front of the name. In this case, we can number from either end. We can say 2-fluoropropane because the main chain contains 3 carbons. It is a propane. So we can say 2-fluoropropane. In this case, so what is the main chain? The main chain, we can locate the main chain like this. And then if you, or there's another way that you can do this. Or like this. Either way is fine. Now, however, one of the methyl group is a substituent in this case, in addition to the chloro group. So chloro is one substituent and methyl is another substituent. So there are two substituents. So in this case, again, you need to start writing the name from the chloro position because according to the alphabetical order, you have to write chloro first. So chloro group is in the second carbon and methyl group is in the second carbon. So you need to write it as 2-chloro-2-methyl propane. Methyl is one substituent and chloro is another substituent. Since this has 3 carbon atoms, it is a propane. So 2-chloro-2-methylpropane is the correct name. As you see, all of these four compounds have their own common names as well. Um, if you are asked to write the IUPAC names, you have to go with the IUPAC conventions, just like given here. Okay, let's do some examples to draw the condensed structural and line angle formulas for 2,3-dimethylbutane. Now you can pause the video and try to do this problem by your own and then come back and let's do the, you can come back and check your answer. Now, to draw the condensed structural and line angle formula, I will first draw the condensed structural formula. 2,3-dimethylbutane. First, I will see what type of compound it is. It is a butane. So I will start with the known fact. If it's a butane, it has to have 4 carbon atoms. And then it says there are dimethyl, means there are 2, di is for 2 methyl groups. So where are these 2 methyl groups? Now the position is numbered here. So when there's a comma, that means there are 2 positions. Always the 2 positions are separated by a comma because both of them are methyl groups. So it's separated by a comma. It says one methyl is in the second carbon and the other methyl is in the third carbon. Now, first of all, I'm going to number this carbon chain. Now, one methyl is in second carbon and the other one is in the third carbon. Now this is the condensed structural formula. Let me go back to the normal screening. So it erased. Let me draw it again. So I numbered it like this. Okay, this is how it looked like. Now I do have this condensed structural formula. So I still have to do one more thing. I will fill up the other carbons with the correct number of hydrogen atoms. This will be a CH and CH. So this is, the question is a condensed structural formula. If it is a condensed structural formula, I don't want to draw this dashed line. I will just write it as CH and CH. Okay, and the other one is the line angle formula. So I will just convert this into a line angle formula for butane. I will draw it like this. And in the second and third positions, I have to draw another methyl group. I will just draw it like this. So now you can count like 1, 2, 3, 4. There are 4 carbon atoms in the main chain and methyl groups in the 2 corners. So this is the answer for the condensed structural and line angle formulas for 2,3-dimethylbutane.